The next topic that we discuss is unit conversions. So, converting from one unit to another is a really important skill for people working in the health sciences. A very obvious example of this is performing unit conversions associated with dosing calculations. So, to perform unit conversions, we will most commonly use conversion factors. Conversion factors are fractions. They are special fractions that have equivalent quantities in both the numerator and the denominator, but those quantities are expressed in different units. For example, previously we learned that 1 centimeter is equivalent to 10 to the minus 2 meters. This is because the metric prefix centi means the same thing as 10 to the minus 2. So using these equivalent quantities, we can create two fractions or conversion factors. In our first conversion factor here, we have 1 centimeter divided by 10 to the minus 2 meters. And in the second conversion factor, we have 10 to the minus 2 meters divided by 1 centimeter. And so what you see here is that we have equivalent quantities on both the top and the bottom line, but those quantities have different units. Because these conversion factors have equivalent quantities in both the numerator and denominator, their mathematical value is actually 1. This means if we multiply a number by a conversion factor, we won't change the size of the number, but what we will do is switch the units. A couple of common ways of using conversion factors within the metric system of numbers is to either add or remove a metric prefix or change a metric prefix from one type of prefix to another. Adding or removing a metric prefix can be achieved using one conversion factor. For example, I might want to add in the prefix milli, or I might want to remove the prefix centi. Changing a metric prefix from one kind of prefix to another is a little more complicated and involves the use of two conversion factors. For example, I might want to change the metric prefix milli to the prefix micro, or might want to change the metric prefix milli to the prefix deci. Both of those operations will require two conversion factors. To help us be successful in performing unit conversions, we're going to use the technique of dimensional analysis. In dimensional analysis, we use the units to help us confirm that we've set up the unit conversion calculation correctly. What we're going to do in this method is treat the units algebraically. That is, we're going to multiply units, we're going to divide units, and we're going to cancel units. Typically, we'll do this through 3 steps. In the first step, we'll write what we're given on the left of the page with its associated units, and then we'll write the units that we're trying to convert into on the right of the page. In the second step, we'll multiply our given number by one or more conversion factors in order to achieve the units that we want. Once we have confirmed by cancelling units that we're able to achieve the units that we want, we'll then put the numbers into the calculator and perform the calculation. So in this first example, we're asked how many centimeters are there in 3.55 meters. So we're performing a unit conversion where we are adding in a metric prefix. So I know that this is going to be 1 conversion factor. So step 1, we're going to write what is given on the left of the page, and then we're going to write the units for what we want on the right. The second step is perhaps the most complex of all of this, is we need to identify the conversion factor that cancels meters and leaves centimeters remaining. So 3.55 meters, and we have to multiply by a conversion factor that cancels meters. So we must have meters on the bottom line. And then we want centimeters remaining, so that means that centimeters has to go on the top line. Now we need two things that are equivalent to each other on the top and the bottom here. So we need to think about how are centimeters related to meters. Well, 1 centimeter is equivalent to 10 to the minus 2 meters. So my 1 goes there, and my 10 to the minus 2 goes there. So at the end of my second step, things are going to look a little like that. Thirdly, we're going to cancel out the units that we can and check that the units that remain are what we want. And in this case, it's worked, so that tells me that everything is set up properly. So now I can go ahead and put those numbers into my calculator. And there is my final answer. And to make my professor's life easy, I put a box around it so that they could easily find that answer and score me correctly. So what are we doing in this method? Well, we're going to take some quantity in the old units. We're going to multiply by 1 or more appropriate conversion factors, and that's going to give us the same quantity but with different units. So here's an exercise taken from the book. It says the average volume of blood in an adult male is 4.7 liters. What is this volume in milliliters? So again, all we're doing here is adding in a prefix. So that tells me I'm going to be using 1 conversion factor. So let's set up what's got to happen here. We have 4.7 liters, and we want to turn that into milliliters. So this is my step 1 here. So obviously the best thing to do here is multiply by the conversion factor that has liters on the bottom in order to make sure that liters cancels, and milliliters on the top because that's what I want in my answer. Now my conversion factor has to have equivalent things on the top and the bottom, and I know that in 1 milliliter there are 10 to the minus 3 liters, and I know this because milli means 10 to the minus 3. So I think I've identified my correct conversion factor. I'm just going to cancel my units to confirm that and check what remains. Everything looks good, and then I can put that into my calculator and get my correct converted number. Just a little note off to the side here. Be sure your answer is always rounded to the correct number of significant figures. In this case, my original measurement had 2 significant figures. So I want to make sure that my answer at the end also has 2 significant figures. Okay, here is another example from the book. This one, it reads, convert 43.007 milligrams to kilograms in one multi-step calculation. Okay, so step 1, we're going to write out what was given on the left, and then we're going to write the desired units on the right. And what I can see here is that this is an example where I am changing a metric prefix. I'm changing from milli to kilo. So I know that this is going to require 2 conversion factors. So I always think about changing a metric prefix as like changing your socks. First of all, you need to take off the old socks, and then you need to put on the new socks. So what we're going to do here is we're going to use our first conversion factor to remove the prefix milli, get rid of that guy, and then we're going to put on our new conversion factor, kilo. So when I'm setting this up, the first thing I want to do is multiply by the conversion factor that gets rid of milligrams. And for that reason, I put milligrams on the bottom there. And then I want to replace that with grams. And so for that reason, I put grams on the top. Now what I want to ask myself is, how are milligrams and grams related? Well, I have to recall that the prefix milli means just 10 to the minus 3. So 1 milligram is equivalent to 10 to the minus 3 grams. So I think I got my first conversion factor. For my second conversion factor, I want to get rid of grams and replace it with kilograms. So it makes sense to put grams on the bottom and kilograms on the top. So having the grams there will get rid of grams, and then I want to turn those into kilograms. And so now I have to remember, how are grams and kilograms related? And I know that in 1 kilogram there are 10 to the 3 grams, because kilo means 10 to the 3. So it looks like I've got my conversion factors all set up correctly. What I'm going to do now is just check that my units cancel the way that I'm expecting, and the only unit that remains is kilogram. So now I'm going to go ahead and perform the calculation, knowing that I have everything set up correctly, and I'm going to make sure that I don't change the number of significant figures. So I started with 5 significant figures and I ended with 5 significant figures. So those are the common ways that conversion factors are used to interconvert between different metric units, but we've been focusing on different metric units of the same type. It's also possible to construct conversion factors for converting between different kinds of units. And probably the most famous one is using the density as a conversion factor to convert between mass and volume. So let's consider some density data for mercury. If I weigh 1 milliliter of mercury, I will find that it weighs 13.6 grams. So what this really means is 13.6 grams of mercury is exactly equivalent to 1 milliliter of mercury. And just like we did before, we can use this relationship to construct 2 conversion factors. We can say that there are 13.6 grams of mercury for every 1 milliliter of mercury, and there is 1 milliliter of mercury for every 13.6 grams of mercury. So depending on what we want to cancel and what we want to convert our number into, we can use either of these 2 conversion factors to interchange between grams and milliliters. We just have to pick the correct one. So this question asks, what is the volume of 100 grams of air if the density is 1.3 grams per litre. So this is really telling me that 1.3 grams of air is the same as 1 litre of air, or 1 litre of air is the same as 1.3 grams of air. So let's set up what it is that we want to do. We write the number that's given on the left, and then we write the units that we want to convert into on the right. So what this is really telling us is I'm going to have to multiply by a conversion factor that removes grams and leaves me with litres. So this one won't work because the 2 grams would multiply together, but this is the one that I need to use, right? You can see that this guy is going to cancel out grams and leave me with litres. So I choose the correct conversion factor, and then I just double check that my units cancel the way I'm hoping, and that I have the units left that I want, and then we can put that into the calculator. Now, in this case, we have 2 numbers. This one has 4 significant figures, and this one has only 2 significant figures. So my answer here, you can see I have rounded to 2 significant figures. A complication that can arise when performing unit conversions is when the unit that we are converting into or out of has an exponent. In this problem, we're asked to convert the volume of a can of soda that contains 375 milliliters into cubic feet. So step 1 is to write what is given with its units on the left, and then write the units that we want to convert into on the right. And when I do this, I realize immediately that my unit that I'm converting into has an exponent. It has the exponent of 3. So I'm smart. So I realize that probably the best way of doing this is to go from milliliters to cubic centimeters to inches cubed, and then finally onto feet cubed. And the reason that I chose to do that is because I knew how these things were related. I knew that 1 milliliter was equivalent to 1 centimeter cubed. I knew that 1 inch was equivalent to 2.54 centimeters, and I knew that 12 inches was equivalent to 1 foot. So that's why I chose that particular pathway. So I'm going to go milliliters, centimeters cubed, inch cubed, feet cubed. So my first conversion factor has to cancel milliliters and turn my milliliters into centimeters. So I put milliliters on the bottom and centimeters on the top. The numbers that go into my conversion factor, I'm just getting from my equivalency up here. Now here's where it gets a little bit unusual. I now have to get rid of the centimeters and turn them into inches. So I want a conversion factor that has centimeters on the bottom line and inches on the top line. But what's important is I have to remember to cube my conversion factor. If I don't cube my conversion factor, I will be incorrect. So I've got my units in place, and then I know that for every 1 inch, that is equivalent to 2.54 centimeters. So now I want to go from inch cubed to feet cubed. So I have to multiply by the conversion factor that has inches on the bottom line and feet on the top line. And what I don't want to do is to forget to cube it because we're converting into feet cubed. So, because I know that 12 inches are equivalent to 1 foot, I'm going to put a 12 beside the inches and a 1 beside the feet. Okay, so it looks like everything is set up correctly. I'm just going to double check that all my units cancel. So milliliters goes, centimeters goes, inches go, and the only thing that remains are foot cubed. So at that point, I put everything into my calculator, and then whatever answer I get, I'm going to round to 3 significant figures. So that's a pretty complicated example. If we were going from feet squared to inches squared, we would just have to remember, instead of cubing our conversion factor, we will square it. Okay? So whatever the exponent is in your unit, that's what you have to do to your conversion factor. It's just an additional step. You just got to not forget to do it. So in both chemistry and health sciences, often our measurements will involve more than one unit. That is, they'll have complex units. So for example, if I am talking about a speed, then I will often talk about miles per hour. And you can see my unit here, it has more than one measurement in it. It has a measurement of distance, and it also has a measurement of time. If I have a density of 3 grams per liter, you can see that I have a unit of mass in grams, and then I also have a unit of liters, which is a volume. So if I was performing a conversion on 3 grams per liter, I might convert just the liters, or I might convert just the grams, or maybe I convert both. And it can get really complicated in health sciences when you're doing dosing calculations. It's not uncommon for people to talk about things like milligrams per milliliter per second, in which case you would have both mass, volume, and time all in the one problem, and you could have to convert all 3 of those things in the one problem. So here's a kind of it's not really related to health science, but it's an interesting example of how we might tackle this kind of problem. It says global emissions of carbon dioxide are estimated at 2 by 10 to the 9 tons per year. Convert this rate to pounds per hour. So what you can see here is that there are 2 things that need to be done. I need to take the tons and turn them into pounds, but I also have to take the years and turn them into hours. So let's try to figure this out, right? 2 by 10 to the 9 tons for every 1 year. So I'm going to do this conversion first, and I looked it up, and I found that there were 2,000 pounds in 1 ton. So I want to make sure that tons are on the bottom here so that they cancel out, and pounds are on the top because that's what I want in my final answer. But now I have to convert my years into hours, and I don't know how to do that in one step. So the first thing that I'm going to do is I'm going to convert it into days, because I do know how many days are in a year. So because in my original number, years are on the bottom, I want years on the top line of my conversion factor here so that they cancel out, and then I want days on the bottom. So I know that in 1 year there are 365.25 days. And so that's going to cancel out my years and leave me with days. Now, I don't want days, I want hours. So I'm going to have to keep going. So I need to multiply by the conversion factor that will cancel days and replace it with hours. And fortunately, I recalled that in one day, there are 24 hours. So I'm going to multiply by the conversion factor that has days on the top line and hours on the bottom line to make sure that my days cancels out and my hours remain. And that looks pretty good. The only units left are pounds and hours. So I can go ahead and put that into my calculator. And I'm going to make sure that I round off to 2 significant figures because that's how many digits I had to start with. Okay, so that concludes the section on unit conversions and brings us to an end to chapter 1.